Welcome to today's part of this SPSS methodology, this time with a unit on partitioning cluster analysis. As mentioned in the part on hierarchical clusters, there's basically two approaches to it, hierarchical and partitioning. There are some more, but these are usually the most commonly used versions. And one of the difference between the two approaches is that if you want to work exploratory, hierarchical cluster analysis is way better suited, because this allows you to find the best cluster number on your own, whereas partitioning cluster analysis needs a specifically set amount of clusters beforehand. Well, with this in mind, how could we run a partitioning cluster analysis in SPSS? For this, cluster is always about categorization, classification of data. So we go to Analyze, Classify our data, and here we have the k-means cluster analysis method. K-means in this case is a representative of the class of partitioning clustering algorithms. So we click here, k-means. Then we select the variables which need to be considered in this case. So here let's go with spendings in total, age, people in household, and income, and let him generate 4 different clusters. This is the first part we need to put into this one here. We can then do some changes. For example, with options, I could get an ANOVA analysis, and with save, I can decide whether I want to save the cluster memberships. So, which observation is assigned to which cluster. So this is something which I can do in addition if I want to need the information for later analysis, for example in the context of a variance analysis or in the context of regression analysis. So here we keep it as it is and click OK. And we see he starts making 4 clusters and determines initial cluster centers, tries to find better cluster samples. So in the end he gets to this result. We see it's only slightly off. The 2 in the middle even stay the same, at least regarding the spendings. Regarding all of them. The other ones change slightly. And then we see here the assignments. He says cluster 1, which is basically this cluster here, contains 3. This cluster 2 contains only 1, cluster 3 contains only 1, and cluster 4 contains the other 5 observations. So this could be used, and then we not only get the information how many clusters are there in each cluster, but we could save this assignment, and by knowing about the cluster centers we could do some comparisons. So here, if we take a look at the different parts, we see those are usually the low spenders, which are more older than the other people but have a significantly higher income. On the other hand, that's the younger people who spend decently enough amount, or more or less, let's say rather a medium amount of money, but have a high income. That's a different group. That's low income and low spendings. That's higher but not high income, but high spending on fashion and clothing. So also the youngest ones, so this is the younger people with the most fashion expenditures. This is the people with the least income and the second least spendings. This is the older people which spend quite little. So this could be our idea, to put names to the different clusters. So we could call them old little spenders. We could call them high spenders. We could refer to them as high income above average spending. We could refer to them as low income group. Just to have a first impression what those groups are about. Here in this case, well, we only have 10 different observations, so it's rather problematic to come up with fitting names. This is also a different thing which can be mentioned comparing hierarchical and partitioning cluster analysis. This type of analysis can easily be done for a lot of observations, because we do not need any kind of graphical support. Doing hierarchical analysis without the help of a dendrogram or trying to find the most suitable cluster size using the coefficients from our table, that's rather problematic if I have a lot of observations. So hierarchical is more suited to small data sets, whereas here our partitioning approach is more suited to large data sets. With this in mind, we can finish this session. As I said, we can also save our results and analyze them further. However, that will be part of a future session. In this context, I want to finish this lecture by hoping that you learned something from it and you enjoyed listening to it. And well, if you're interested in hearing more on this topic, feel free to visit the rest of the videos on SPSS methodology, and see you and goodbye.